Hi, so great afternoon, everyone. I hope you've been having a great day, and thank you for attending this seminar. Today is my presentation. So, a brief background on me. I acquired my Bachelor's of Science in Electrical Engineering here at ETSA in about 2020. Afterwards, I really enjoyed my time here at ETSA, so I decided to pursue my master's, and presently I am attempting to acquire my PhD, also in electrical engineering. A little bit of my experience prior to this point includes a few internships over the summer and some work experience that's relevant. Two of those internships included my time at the Air Force Civilian Service, one 17th Air Force Base, and the other in Maryland. At Tinker Air Force Base, it was my first internship. It was during COVID, so they were very kind to offer us a few weeks to spend time with them. There, I got an introduction to network engineering. I also got an introduction to Zero Trust and Enterprise as a Service. And one of the products of our time there was to make a report on how the military can ingest enterprise information as a service into their infrastructure, as well as if they can integrate Zero Trust and still achieve the same functionality while also integrating the really great security of that technology. My second internship at the Air Force Civilian Service was at a different location and consisted of a whirlwind of many tasks. I learned so many things, and it was just a very great experience that I'm very grateful for. A few of the things that I did there was I learned a few new programming languages in a really short time, and we had to use that to make other new tools or just to help look at existing tools and see if there's any vulnerabilities that we can leverage for our advantage. In the next few years, I spent some time during the academic year, both working with Sandia National Laboratory part-time, while also attending some summer internships and doing research in the Clear Lab. So at Sandia National Laboratory, that was collaborating with UTSA, our big objective was seeing if sensors inside of Windows machines could detect if a cyber attack was occurring. And we leveraged the MITRE ATT&CK Office 365 framework, as well as a lot of information on Windows sensors to discern if that was true or not. All the while, I was attending an internship at Lawrence Livermore National Laboratory, where my big objective was really to research water and wastewater critical infrastructure, and then also to look at an existing simulation tool and install some expedited features so we can test to see if that tool works as expected. And then very finally, my last internship in the summer of 2023 included a very engaging internship at MITRE. I was employed as a cyber resiliency intern, which was definitely a shift from my normal tasks. But from there, I was expected to assess the cyber resiliency of critical infrastructure or critical system rather, and then report that to leadership as well as to MITRE and propose some new technologies that would help them with resiliency. So my motivation going into research, I started research as an undergraduate, and it all started really with my time with Dr. Prevost. So Dr. Prevost, he offers a C++ and data structures class, and I've taken a few programming classes beforehand, but his class was just very challenging. He introduced, of course, all the topics in C++, but he uh, tasked us to do really hard projects, or what seemed to be hard to me at the time, and really had to push me past my comfort zone. I could no longer make some sort of application or tool just for it to work. I actually had to like understand what was happening. I couldn't just be so reckless and haphazard and make it willy-nilly. And it really pushed me to understand programming a lot more and then go into a project with a lot of structure so that it can achieve success. And I look back at my time as an undergraduate and I recognized how unique that experience was, even considering all the internships that I've had. It's a pretty unique opportunity. Sometimes in my internships, I noticed that you're given kind of just a project that may not seem terribly engaging or motivating. And here in research, I felt I was pushed to actually be better than who I used to be. And so that's why I decided that I wanted to continue research over time. Additionally, it was my opportunity to learn new skills and then to make new tools and applications. So from my time in research, and many of you may relate to this, as individuals in engineering or science, we may have this desire to make something, an application or a tool. And, what if the magical day happens to where we do make a tool that's really useful? It does so many amazing things and it actually gains a lot of popularity. A lot of people start using it. In the event that people do start using it, people may start ingesting information such as their name, maybe their phone number, maybe their email address, and maybe their credit card information. And that makes a really fun app that has a lot of functionality, but that also makes an app that's a bit of a target. Many bad people may look at that app as some sort of vector to access personal information. And if they're successful exploiting any vulnerabilities or weaknesses in your application, then they can acquire your personal information and use it for whatever purpose they may have afterwards. And that's why it's significant that we consider always the functionality of an app and how fast it is, and all these bells and whistles that we'd like to add, but also the security. So that's what started my interest in cloud computing, edge computing, and blockchain technology. So a brief introduction to edge computing and cloud computing, if anyone's new to it. Edge computing is a myriad of devices, any device really that is that has a TCP/IP stack, any device that can connect to the internet. This includes your phone, devices that are inside of your car, embedded devices that are sending communication to another device. This includes your smart vacuum cleaner, your smart refrigerator. It's a myriad of these devices, and these devices typically have embedded systems that are pretty weak. They're limited and intentionally made to just do really minor processing. And so with edge computing, the big objective with these devices is for them to acquire information from one dedicated source. And we typically SAN security at that point, with the objective of really just having privacy and having these devices propagate this information to another dedicated device, like an edge node or an edge server, which may have a bit more processing power to install some more security. These edge nodes or servers may include microprocessors like Raspberry Pi that you're familiar with, and these devices are responsible for acquiring and aggregating as much data as they can, and then propagating that up to more resilient and more secure computing resources such as the cloud. And in the cloud, that's when we can start doing things that have maybe more low latency. So this includes processing really heavy data, and also just acquiring access to databases so that we can have this framework of fast acquisition of data that propagates to a source, and we can do processing subsequently later, and then storage later. We recognize this as a necessary tool because we'd like to maintain speed in every application that we have, while also being flexible enough to handle really big data, such as like images or videos. Integrate other technologies like blockchain technology. If you're new to blockchain technology is not anything terribly new. It is essentially just a decentralized service, and it's also a network. So typically with blockchain technology, people use it for the major objectives of hosting their digital assets. So say, for example, if you have a right to property, physical property like a car, you can have a digital title, and that proves your ownership of that physical property, and that lives on the blockchain. You can have apps or services. Essentially, these are just apps that live on the blockchain that you can interact with and do smart contracts. Or you can use blockchain as essentially just a ledger, a big database that'll always hold your data. It will never change your data, and this data will persist on multiple nodes across the world. So blockchain technology will do all these features through just a very short sequence of actions where a customer can submit a transaction request. This transaction request will be allocated to a node that exists on the blockchain. That node is responsible for processing your transaction and validating that your transaction checks a few minor checkboxes, such as your digital signature, and maybe that the transaction is valid. And then upon achieving those major steps, the blockchain node will package your transaction into a block and will propagate that across the entire network over time for that block to be appended onto every ledger that exists. And that block will never be changed. So thus we can concatenate this blockchain technology, this immutable transaction, this immutable block, with the speed of acquiring data at the edge, and then also the processing power that we get at the cloud, and then aggregate that into a framework for us to push data into that system and have some resiliency before we use that data for a subsequent process. So our research essentially does this, where we leverage a few microcontrollers such as the Arduino, and the Arduino is reading data from a sensor for an experiment. It was temperature sensor. And then the Arduino is propagating that data to our edge device, and our edge device is a Raspberry Pi that is dedicated to doing a few tasks, which includes having a publish subscribe feature such as a QTT, while also having an application open to communicate with the Ethereum blockchain, and then also having another application open to communicating with the cloud. And it'll send new data to both the Ethereum blockchain and the cloud at the same time. The objective is that the cloud will receive that data typically faster, and will maybe start processing that data before or all at the same time that the Ethereum smart contract is processing the new transaction, and that transaction gets validated and committed onto the blockchain. Upon proof that that block does exist in the blockchain, then as the cloud finishes its processing, then it'll check to see if that data was true on the blockchain, and then it'll send that data back to the Raspberry Pi and then to the Arduino to control some subsequent sensor. All the while, we can install a dashboard to visualize all this information just for a user's point of view, and then we have a lot more confidence that this data has not been modified and comes from the source that we intended is from the user that initially sent this data. And we can trust that transaction a lot more. To my postgraduate plans, I'm presently in the scholarship or service program. So I am committed to the public sector for quite a bit of time, but I am going to take all this research that I've acquired, and I've developed a really strong interest in assessing the vulnerabilities of devices such as the Arduino and the Raspberry Pi, and then also assessing the robustness of these devices, mostly to see if they can be compromised. And if I'm successful compromising them, then the big objective is always to secure these devices that we make and the applications that we make. And with that, I'd like to interrupt any questions.
Alrighty, thank you so much, Aura. That was a great presentation.
Or I do have a question. I don't know if you can hear me okay.
Yes, ma'am.
So I know you're talking about all the types of, the research that you're working on in the Clear Lab. I do know that we've got other honorees who are also joining us today. Can you speak a little bit about maybe the research that you're doing in conjunction with Stephanie? Are y'all doing, different projects? Are you thinking of maybe collaborating on something? And follow up to that is, are there any publications in the pipeline that we can, hope to see in the future?
Absolutely. So Stephanie is working on quantum computing topics. I will tell you, I admire her so much for approaching those topics. I've taken a few quantum classes, and respectfully, I know that that is not my wheelhouse. But I am looking for, if she does have an opportunity for me to segue my research with hers, I would be glad to. With regards to present publications, so I do have my master's thesis, which is on assessing the throughput of the private blockchain Hyperledger Fabric, and seeing essentially how efficient it is using the Markovian chain model, which is essentially just a large state machine. But future research will consist of assessing device vulnerabilities. So this includes other devices. So we mentioned earlier the Raspberry Pi. Is that vulnerable to an attacker using man in the middle or breaking SSH or HTTPS? Or, of course, that's involved in SSH. But we'll be assessing the vulnerability of other devices like FPGAs. And hopefully we can report those as best as we can. We're presently interested in assessing the vulnerability of devices that belong to the company, but if we can publish anything, I would definitely love to show that.
Wonderful. And if that's something that we can also add to a follow-up or, just a closure of this may be shared in the link, or that's something we can also share on our YouTube channel, we'd be very happy to do that as well for yourself and all the honorees who were showcased this year. Thank you so much.
Absolutely, thank you.
Also, I do have like a question. I'm not like super like I don't have a very deep understanding on blockchain, but pretty much things that we watch like on some videos and stuff like that. And I know that like Bitcoin and cryptocurrencies, they are in the blockchain. So the purpose like of your project differentiating with the blockchain that is already currently like in the cryptocurrencies and stuff like that, what would be like one like certain types of differences according like to check vulnerabilities and everything?
So what would be the difference between blockchain and cryptocurrency possibly? Or did I get that right?
Yes.
Absolutely. So cryptocurrency is typically a reward. It can be used honestly on two fronts. So if anybody's heard of blockchain mining, this is a reward for individuals supporting this peer-to-peer network. So earlier we mentioned that blockchain is a decentralized service. How does that vary from a centralized service? Well, it's essentially anybody that's willing to host a portion of the blockchain on their personal computer or any computer that can handle that computational load. Please allocate some of your space towards incoming transactions and making blocks. Anybody who is allowing for the computer to handle such hefty transactions gets compensated with some sort of currency. And this is your cryptocurrency. These cryptocurrencies, goodness, I don't really get into making custom cryptocurrencies and assessing the vulnerabilities of those. So I definitely can't speak to that. But they are an artifact that's produced from essentially devices supporting the continuation of blockchain.
I got it. Yes. Yeah, it's like a curiosity that, I just whenever I was watching your video, also I was watching like with my boyfriend and we were talking about, oh, this have something to do with like the blockchain, cryptocurrencies and stuff because we're very into cryptocurrencies, but it's very interesting topic. Thank you.
Yes, as I hear a lot of individuals making new cryptocurrencies, I I'm deeply enamored by everybody making new cryptocurrencies. Unfortunately, I don't know how to make cryptocurrencies. I only know how to make the network you can probably use to mine cryptocurrencies.
Yes. Yes, but thank you, Aura.
Thank you for the question.
I have one last one if that's all right. So I just want to know what drew you to this specific research topic. I think that in the whole world of cloud computing, it's very interesting for me as an outsider to learn about the individual like segments of it all. So I want to know what drove you specifically to choose this research topic.
Absolutely. So I all throughout my time as an electrical engineering student, I think attending these programming classes, you get quickly enamored by the idea of being creative, using your programming skills to make web applications. You get very excited when you make your first device talk to another device. You get very excited when you make your first app. And so those gears are just driving, telling you like, well, let's make stuff, let's be an inventor. And so it's always very exciting to make something. But very sparsely do we consider, is this secure? So as significant as it is, and as fun as it is to make a device, it is consider it may be hazardous, honestly, to make a device or an application and not consider the security of that application. So I have to translate my interest over to security.
Thank you. That was very interesting. Again, that was a great presentation. Thank you so much for doing this and being part of this seminar.
Absolutely. Thank you, everyone.
Aura, I do have one more question, just because it's information related but unrelated. This goes back to what is the plan, post graduation. I know you mentioned you're part of Scholarship for Service program. Are you able to speak to that just a little bit more in detail, or give us an idea of what that entails and how it's governed?
Absolutely, if anybody's curious. So the Scholarship for Service program is an interest to attract talent, typically undergraduates, but you can most definitely be a graduate and enter that program. They have a strong interest in individuals who are interested in cyber, and that includes all aspects of cyber. So that includes individuals who do mathematics for cryptography, cyber policy, cyber security, and even individuals like me who do electrical engineering, anybody who can contribute to the cyber workforce. The interest is for these individuals to be interested in the public sector and donating their talent, but allocating their talent towards the public sector, because we recognize that, Google, Facebook, Netflix, they're all big players. They're all willing to pay a lot of money. And so a lot of people who go into cyber topics may be attracted to those companies, and they get this aggregation of talent. And that's because of the money that they're willing to spend on their talent, but the public sector is fixed to just giving a certain salary. So it may not be as attractive for a recent graduate to go into the public sector. However, the public sector has just as many needs and will provide just as many very enticing projects as a private sector will. So the Scholarship for Service is an interest in introducing undergraduates who have roughly about 2 to 3, if not less, years left until they graduate. You are intended to spend your summers at an internship, and it's highly encouraged. If you cannot, then you have to justify why. And your summers will be spent at a public institution, working with the federal government, local government, or a tribal government or tribal state government. And you can work on a myriad of projects. You can also work at a national lab as well. They qualify. And the expectation, in addition to you getting funded for going to school for those years that you're committing, is that for every year that you're funded, you have to donate or give your time back to the public sector. So you have to pick a place that you really like, maybe an internship or a new place that you applied to. And then you have to give every year that you spent getting funded with that organization to satisfy the Scholarship for Service. And the hope is that you stay. However, no one's pointing a gun to your head saying, you have to after your term.
Well, thank you. That's very interesting. I would very much like to get maybe a link to this program as well. I think, any opportunity that we can afford our students is all good information. Of course, going back to anything that we can give back to our, public sector is also a good opportunity for UTSA and UTSA graduates.
Of course, I can definitely give you the emails for the PIs for the program here at UTSA.
Thank you, Aura.
Yes, thank you so much. So, are there any other questions before we wrap up? Alrighty, so I think that that was just about it. We're going to go ahead and stop the recording, and this will be shared to our website and our YouTube channel again. Aura, thank you so much for presenting. You did a great job. And thank you to all of our honorees. You guys all did a great job in your presentations. It was really interesting to learn about all of your research and the exciting work you're doing for cloud. I'm going to go ahead and give y'all 30 minutes of your day back. Thank y'all. Have a great day.
Thank you.
Bye.
Thank you.